Well, y'all remember my vintage Buffalo drill press that I restored? Well, now we're going to make it into a milling machine. Well, we already have. And, oh yeah, lots more to come on this too. So hold on to your hats. I've got to get this piece down so it's narrow enough to fit in the holder on my lathe. I'm putting a quick change bit holder on my lathe, and the part that comes with it to mount it to is too thick and too wide, so we have to mill it. So the shade-free fix-it man has come up with his own lathe, don't you know? Okay, we're going to make our last pass now. We're down to the scribe line that I had put on. So we're going to crank her up and let her go. Give it a little more oil. So I have started milling the thickness of my part, and I have never done machine work before other than working on the lathe. I've never used a mill or anything like that. I'm not sure if I should be turning faster, but it's on the slowest speed that my Buffalo drill press will go. I have my magnetic chuck here, and I can tell you right now, the magnetic chuck won't hold it in every position totally firmly. I had to make modifications and make brackets to mount it on my cross slide vise, and I found that I thought first I would come from the back side over here and come forward, and that kicked it. The magnet wouldn't hold it, and I started on the front on that side and the magnet wouldn't hold it. So now I have moved and I am going front to back on what is my right side. We'll see how we do. I've gone less than halfway through. So far it seems to be working okay. Taking about a 1/16 of an inch off on each pass. Don't know if that's right or wrong. I got to do more investigation. Looking down on the piece, the bit is turning in a clockwise direction. We'll do a little sweeping here with my acid brush, and you can see it's nice and smooth. Has a little bit of ripple effect there, but that might be part of it. Might be some of the vibrations from the drill press and all of those things. Everything is anchored down tight, and that's one thing I found out right off the bat. Everything has to be tight or it just won't work. Any movement anywhere. And I had to actually make some brackets to hold my magnetic chuck, and finished doing those, and I'll show you that afterwards. I'm going to back it across and take one more cut with this blade before I decide to change over to the larger end mill. Invested in this milling machine. That includes the price that I paid for the drill press. Doesn't include the time and materials I put into restoring it, although most of the restoring was just cleaning and painting. I paid $40 for the cross slide vise from Facebook, and I think I paid $65 for the magnetic chuck. So that's $105 right there, and you can see that my part has just turned. It's not staying straight. The chuck isn't holding it. You'll see that when I clean the chips off. I wonder if that wouldn't do that so much if I had a larger bit on it. I have a 1/2 inch bit. You can see right there what happened when it got to my hole in the middle and it had to start cutting again. It veered off, and you can see that my piece has twisted in place. All I have to do is twist this piece here and see. Now my magnetic chuck comes loose. So if I clean it up really well, because I still have, oh, probably 3/16 to go. You see the line that I scribed on there? That's what I got to go down to. Well, I'm back at it again, and I have a few comments to make about using your drill press as a milling machine. Because I had such a thin piece that couldn't be mounted in the chuck itself on my transverse vise, I bought a magnetic chuck. And you can see that right there. It says magnetic chuck. And I have it on. Let me release it. And I can move my, let me pull my thing up. You can take it right off, take your part off. And because it was so small and because of the position of everything on my table, I put a spacer in the back. And the spacer hasn't made any difference as far as the function. You can see with the magnetic part turned off, I can clean it off. And I have used, I've been doing it dry because I was using a cutting edge, cutting oil before, and it made it more susceptible to my part sliding. So now I'm going to reconnect it. All I do is turn that lever like that, and that makes it pretty solid on there. But it's not impervious to moving. And if the bit catches, it will kick your piece out. And I have a homemade rig to hold my magnetic chuck onto my transverse vise. Let me lower you down so you can see that. Now, if you look real carefully, maybe I can bring my light out here so you can see it better. Yeah, I have 2 angle iron pieces, 1 angle iron and then 1 extra piece welded to it to grab a hold of this. The way this is meant to be mounted is on a cross slide that has slots in it. So this would go into the, it has actually slots on the side there for these to hook into and then be bolted down. Can't do that on this because of the way it's set up. My vise wasn't wide enough this to open up wide enough to put my magnetic chuck in. If I had gotten a smaller one, they do make smaller ones, like a 3-inch, probably would have fit right down in there. But with my experience with this, I'm thinking a 3-inch vise magnetic chuck probably wouldn't have enough power. I don't know that for a fact. This is my first experience with it. So anyway, this is what engages and disengages, and we've got it engaged now. And I have these angle pieces on both sides, and I have this wood spacer in here, keep them from kicking in when I tightened up my chuck on the vise. Now, let me take you back up again. And you've already seen it working before under power, and I used a bigger end mill that I had bought, a 1/2-inch one, and it worked pretty good, but it couldn't take much of a cut. And when you're the biggest part of getting it to work is getting started and ending. Once it's in the middle, it works pretty smoothly, but starting and ending, it sometimes will catch on one of these teeth on the mill. And I have tried going this way, I've tried going this way, I've tried going side to side. It doesn't seem to make much difference one way or the other. So I was going in a square here to try and decide which way was best. And my most success has been going with my table coming forward so that my bit is going back, and just taking a little bit of a cut at a time. It's a slow process. Machining isn't fast anyway. But I still have probably, you probably can't see my line, but I probably still have 3/16 of an inch more to go down. So, yeah, it probably would have been as cost effective to take this little part to the machine shop and let them do the work. I'm thinking they probably could have done it for 30 bucks. And between my cross slide vise and this thing here and buying the bits, you know, I'm probably up to 150 bucks. But I wanted to try it, and I still have some other projects that I want to use for this. When we get back on the Goofy cart, I need to cut a key slot in one of my axles, and this bit here is the exact size that I need for doing that, and I'm pretty sure I can manage to do that on my axle, and so that will serve that purpose. So you've seen enough of it going already. I'm going to finish this project up, and I'll bring you back and show you the end product and show you how it fits over in my lathe to hold my quick change bit holder. Hold on to your hats. Well, I got tired of messing with that magnetic chuck. I guess it would work for some things, but it's not working for this. So we're down to back on the vise itself. I got a wooden spacer in here, and I'm not sure, and that's just under there to keep this from dropping down. It's clamped tight in the vise. Let's see what happens now. Can't walk on me. Still wants to grab and see it jumping. Maybe I'd be better off going crosswise like this. Okay, so let's wrap this up. I finished machining my part on the cross vise without the magnetic chuck. That just kept bouncing around, and even with it in the cross chuck, things on my drill press don't stay where they should be all the time. Everything that mounts on the post is round, so my table would gradually slide over, and sometimes if the bit would catch, you can see what happened here. This was on my was going to be my last pass, and it kicked over, grabbed, and my table gradually went over. So, but we got it. I didn't machine it all the way across. I could have, because the original part that we're replacing is flat all the way across. But I decided that I was going to leave it with some more meat in the middle, because that's where my post grabs. So this slides in here like that, just like that, and then my drop it George, then my quick change tool post drops right on there. And if you have a particular bit set up that you're going to use quite often, and I have another one of these quick change pieces here, you could set the depth with this here, get it up and down. I use that to set my center point, because your bits are supposed to go on the center. Anyway, that's not the point of this. The point of this is we got our piece machined, and now I can just bolt this down tight like this. And if I want to change the bit, all I have to do is slide this up out of here, slide another down that I've already got set, and tighten it, instead of going through the process with this. This is called, I think these are called a lighthouse. Is that right? No, I don't know. But anyway, this part here would slide into that thing. Then this would go over the top of that. And then you have this filler piece that goes underneath that actually holds your bit, goes in here. And then you would have to tip this, slide it in left and right to get it at the right angle and get it pointed in the middle once you were putting your bit in place. So it was a little bit of a process to go through. So we have eliminated that, and now we have our quick change. A couple of things that I would say about using your drill press as a milling machine. It's fun and it works, but don't plan on doing super fine machine work with it, because there is, well, number one, I'm not sure what brand this cross vise is, but it's not super duper tight. You know, the fittings aren't real tight. That's the cross, that's the play in the lead screw that goes that way, and there is play in the lead screw that goes front to back. Then you always have to deal with the run out on your drill press. My drill press is pretty good, but I have found that different bits have more run out than others. And of course, if you're using an old drill press like mine, you got to make sure that your drill press head is anchored on and tight so that it can't move side to side, because they are made to swing. And I had to go through and tighten that up. When I first started, I wasn't paying attention because I had just been using it as a drill press. And then you also have to make sure that your bed is anchored down tight, and it also has the ability to swing. And I found that over a period of time using this as a milling machine, that it would loosen up just enough so that it would creep, and that's what happened at the very end. And I had tightened it up a couple of times in the process, but thankfully it wasn't a problem with my project. I have not determined what is the best speed for doing it. I guess it depends on your material. I found that the slowest speed on my drill press was actually the most efficient. As far as making your depth adjustments, on mine I have this nub that goes into the quill and holds it in place, and if I loosen it up, you see that it's going to go right back up by itself because it's spring loaded. And the only gradations you can use are the ones that are here, and they're not really fine enough for doing fine machining. I did find that I could adjust this and get it about where I wanted it down and set this nut here and then turn in this nub to hold my quill down where I wanted it. But that's not exactly what you would call machining tolerances. So that's something else you need to take into consideration. But I enjoyed the process. Is it efficient? Not for making one part. Now that I have this set up, I'm sure I will probably use it more. I am not happy with my magnetic chuck. It does work, but it doesn't hold it tight enough for the kind of stuff that I was doing anyway. And I had to make these brackets to hold it in my chuck because, and I think I already said this, my chuck is too narrow this way for it to spread out enough to hold the magnetic chuck. I'm sure it'll come in handy for other things. And I have two other different kinds of vices down here that I use on my drill press as well. Finally, you're going to take into consideration the cost of end mills. This one I just bought, I think it was around $20. Didn't get to use it much before it got chipped. Let me see if I can get you down here so you can see the chip in the tooth. See if I can see the chip in the tooth. There it is right there. See that? Chipped right off the point. I don't know what speed it's supposed to run at. I tried it at the lowest speed, and I also tried it at a one step up on my drill press. So I used 4 bits. This one has a chip in it too, on one of the teeth. Right there, I think you can see it. And both of these, you can take my word for it. So 4 bits, you're probably talking between all of them probably $30 there. So it's not efficient that way. But how many other projects are we going to be able to use it for on the Goofy cart that might not be quite so needful of digging deep? So until next time, this is George saying thanks for watching, commenting, subscribing, thumbs up, sharing, all them good things. We're going to be pulling the motor really soon. And one of our machining projects is I'm going to have to machine a slot in this axle. I hope I can do it, because we're going to be putting in a new differential. Getting rid of this split in the axle here so that it'll have a differential so that both wheels can turn and yet have the ability to slip one as you go around corners. Hope y'all are doing good. Bye for now.